Hey, we are going to go ahead and take a look at, this is number 6. So in this video, we'll take a look at a few more problems together, starting with number 6 from your practice test. It says a total of 50 students play soccer or lacrosse, 20 girls play lacrosse, 20 boys play either soccer or lacrosse, and 20 students play soccer. What I would recommend is making the frequency table. So this will be soccer, I'm just going to abbreviate, and then this can be lacrosse. And then we also want to have a space for their totals. And total down here. What this does is it just organizes your information, and because of the information that's given, you can actually figure out more information. So 20 girls play lacrosse. Girls lacrosse, that would be this box right here. We know that's 20. We actually should start even higher than that. 50 students play either soccer or lacrosse. So students all together, the overall total of people that it looks at for here is 50. 20 boys play either soccer or lacrosse. So that means that soccer or lacrosse boys, the total of boys would be over here. It doesn't matter which sport they play, that's just your total of boys. 20 students play soccer. So underneath of soccer, if you go to soccer and then you go down, this one should be 20 because regardless of whether it was a girl or a boy, it should add up to 20. Now we can fill in the other pieces. If we know that there's 20 boys out of the 50, that makes this 30. All of your categories, rows, your columns, they should all add up going across or going up and down. Well, going down. So if there's a total of 30 girls, 20 like lacrosse, then we know that 10 must like soccer. If we know there's 20 total boys, 10 like soccer, 10 have to like, or 10 have to be boys. And then if there are a total of 20 boys and 10 like soccer, 20 like lacrosse, so then, just kidding, 10. And then this would be 30. 10 and 10 is 20. Sorry, I was just looking at the wrong number. So notice that everything adds up going across, everything adds up going up and down, or going down. So if we want to know the probability that a student plays soccer or is a girl, now we can figure it out easily. This is a girl that does play soccer. It says plays soccer or is a girl. So actually this number will count too. They're boys, but they play soccer. So here these people play soccer. This means that it's a girl, and so those are the numbers that we would want to add up. And so we know that 40 out of the 50 total people play soccer or is a girl. Notice the word or. That's one of the things that makes this problem a little different, is that it's or. If it's and, then it would only be you're a girl and you play soccer, nothing else. Since this is an or, that's why we have to make this frequency table and kind of really look at who does what in order to help out. There is also an equation that could help. This is the equation. This is on your end of course exam. That's going to be given to you. If you can find, like, this would mean the probability of being a girl, the probability of playing soccer. But then, because notice if we have 3 things highlighted, you can't count the probability of girl and soccer twice. So girl and soccer could just be subtracted. We will hopefully get to talk about this equation a little bit before our end of course exams as well, but I think it's a lot easier to see it using the frequency table than to worry about the equation anyway. So we will talk about the equation before end of course exams, but the frequency table in this case is very, very helpful. The next problem, a lot of people miss this problem, and when you do, you're going to be very disappointed when you see just how easy this is. If you think of a square, and you think of the fact that if you basically take this view, you know that it goes across, right? One side goes across. Is this the same length as your sides? No. In a square, your sides might be one length. Now, there's a chance that it could be, but in this one, you can even tell. This looks longer, but it's hard to see because of the way it's drawn. You really have to think of depth perception. Since this is a cube, your sides are the same length. So yes, what is on the top, this will be the same length as this, but where this is diagonal, that diagonal is going to be longer. And so this should have been rectangle. So just because the sides are a square, a cross section, the definition of cross section, because this is usually on there every once in a while, and we will see it still this year, but a cross section means that if you just want to basically cut your figure, this is an actual cube, it's like a three-dimensional figure, and you are slicing it right there, then which shape would be created is what this question's asking for. And again, it would be rectangle because this side and this side are actually diagonals of that cube, which makes those sides longer than the ones that are just matched up on the ends. So if you see problems like this, just pay really close attention to the fine details to try to get that one. All right, this is another probability one. One of the things with probability is if you have two events, the probability of A and B, that is also the definition or equation that we will find. Sorry, let me rewrite this. What I was meaning to write was the probability of A and B is equal to the probability of A times the probability of B. So you're really just multiplying. This answer has a lot of different possible answers. All you have to think about is what two numbers could you multiply to equal 0.25. And so there's different possibilities. You could have 0.5 times 0.5. You could have 0.25 times 1. So either of those would be answers. All you had to do for this one was to try to think about two numbers that will multiply to equal that, because this is our general formula for independent events, which is the very first lesson in probability, so we will start that next week. This is one of the problems that deals with circles. This is a lesson that I'm hoping to try to get to a little bit before the exam, but you do want to pay close attention because this has been seen, it was a couple times on last year's test, and it is seen kind of regularly. So what this is this is called an arc. So AC is an arc here. And there's two actual theorems that go with this. So over here on the side, I'm going to show you both of those. But the measure of an angle inscribed in a circle is 1/2 the measure of the intercepted arc. That's exactly what is given here. So if we draw a circle, and this is your arc, and this is your angle here, it's 1/2. So if this were, say, 120, that's going to be 1/2 of that is 60. This is very close to another theorem also. If you have an arc, but this goes to the center, so let's pretend that's right in the middle. If this is 120, but it goes to the center, it's the same measure. But if it goes all the way and actually touches the other side of the circle, then it's half. So this answer should have been 60. So this is half the measure, where if it goes here into the middle, we're going to pretend like that's the center of the circle. If it goes to here, then it would be the same. All right, for the next one, this is also, just in case, I know you're following along hopefully with the assignment, but this is number 10. Whoops, I accidentally clicked for it to go forward. So this is number 10. And with this theorem, we do have plenty of blanks, but we definitely saw these ones earlier in the year, a fair amount of them actually. So let's go ahead and talk about it. It says that WXYZ is a parallelogram. That is given information. Remember, the given's always here, and almost all the time with every theorem, we usually start with the given. Number 2 says that WX is parallel to YZ, and WZ is parallel to XY. So let's go ahead and mark that. It basically just tells us that our opposite sides are parallel because we know that we have a parallelogram. So by the definition of parallelogram, that's how we know. So then it says ZWY. So ZW WY would be this angle right here because the W is in the middle, is congruent to XYW, XYW. And then it also says that ZYW, well, there's another one. We'll get to that. Let's go ahead and talk about this one just for a second, though, because we know we have parallel lines. Anytime that you have parallel lines, you want to think of a transversal. If these are our parallel lines, with the angles that we have marked right now, we could go ahead and draw this line. And what type of angles are these? Alternate interior. So they're alternate because they're on opposite sides of that transversal. Interior because they're in between the lines. If you remember in chapter 3, we had a flow chart where we went over a lot of those. You may want to look over that flow chart in order to kind of refresh your memory on those if needed. And let's go ahead and look at the other angle. If you remember, we had another angles that were posted here. It said ZYW. So ZYW would be this one, is congruent to XWY, which is this one. And those are alternate interior as well. The way that you know this one is if you look at these lines. And let's let this be our transversal. If you do that, you see that they are on opposite sides of your transversal. One's right here, one's right here. But they are in between those parallel lines. So alternate interior angles. If we look at our reasonings then, alternate interior angles are congruent is this one. Make sure you read it closely. I almost circled the one before it, and that's alternate exterior. So there's a lot of answers that are very close, so you do want to make sure you read through them carefully. Alternate interior angles are congruent. Next, WY is congruent to WY. I'm going to take off some of this extra writing that we have on here. But WY is congruent to WY. Hopefully you guys are recognizing these ones still. This is used to make both of those triangles. Anytime that the same line is used to make both things, that is the reflexive. Remember, same thing on both sides. Reflexive is like a mirror. Reflection, reflexive. Now, as we have these marked, we see that our triangles are congruent. Triangles being congruent, these are the only ones that it should be. You should, actually there is no AA either for congruent. You should recognize first exactly what the statement is and narrow it down for anything that you can. Saying that you have congruent triangles are one of those reasons. What do we have then? Well, we know we have an angle, a side, an angle, and so therefore ASA. Side, side, side would mean that we know all the sides are congruent. We do not. We don't even have two sides, so that takes away that one. So this is ASA. CPCTC stands for corresponding parts of congruent triangles are congruent. Right after you have the fact that you have congruent triangles is a lot of times where you're going to see that. Because if we know that those triangles are congruent like we learned in 5, then we do know that WX could be congruent to YZ because they're parts of the triangle. And so the CPCTC would work. I won't be able to write all of that out. One thing I want to point out though, its corresponding parts of congruent triangles are congruent, which is this one. Notice how similar this is. All it does is it changes that last word, but that does make a big difference. Only one of them would have been counted correct. Alright, in this video, we talked about numbers 6 through 10. I think we'll go ahead and stop here for this video. I will make another one for the rest of them, but if you do have any questions at all, just let me know.